This question is going to have some similarities to the previous one, but now we're looking in series form. We want an antiderivative for sine of x squared, right? And then we're going to use that to approximate this integral. So here's the idea. You actually do not have the skill set to find a closed form antiderivative of sine of x squared. It's not existent. It's not just, oh, you can't do it. We don't have a technique for this. So you might try u sub, but u would be x squared. That means du is 2x dx. Uh-oh, I don't have an x. You might try integration by parts. It doesn't work. The only way for us to do an antiderivative or a definite integral of this is to use a series. But the question is the same in that it's also asking for the error to be less than 1/1000th. So I want to integrate this, right? And then I want to make sure that the error is less than 1/1000th. So I'm going to use alternating series error bound. This was sine of x squared. We actually did that on the previous page. So I'd already built this particular series, so I'm not going to go through the process of building that again. So let's start with this integral from 0 to 1 sine of x squared dx is going to be approximated by the integral from 0 to 1 of the series. So x squared minus x to the 6th over 3 factorial plus x to the 10th over 5 factorial. I don't know how many I'm going to need, so I'm just going to use all 4 of these for now. I might need some more. I'll put a dx there. So now let's focus on the antiderivative part. Right, so this is going to be 1/3 x cubed. And then I'm supposed to be adding 1 and then dividing by that same number. So again, I could just make that 42, but 7 times 3 factorial is fine for now. And this is x to the 11th over 11 times 5 factorial minus x to the 15th over 15 times 7 factorial. That could continue if I needed it to, and I'm evaluating this from 0 to 1. Now, good news is that when I plug a 1 in, right, obviously 1 is going to be in my numerator, but when I plug in a 0, the whole second term is going to collapse. So my focus is just on the 1 part. So we're going to do 1 cubed minus 1 over 42 plus, and this is 1 over 11 times 120. Remember, I want my error to be less than 1/1000th, and this term is less, I know I'm getting into this a little bit, than 1/1000th. Let me move that just because I know you can't see it. Okay, so it's less than 1/1000th. So that means I only need 2 terms for my error to be within 1/1000th. So let's go here. We're going to do the integral from 0 to 1 of sine of x squared dx is going to be approximated using a partial sum with 2 terms. And we're going to do 1/3 minus 1 over 42. If you want to leave it like that, that's fine. But it does reduce to 13 over 42. And now the error, which is the remainder, is less than 1 over 11 times 120, which is less than 1/1000th, by alternating series error bound. So if you want to find the actual error, you can ask your calculator to do the integral. Remember, your calculator is just going to use a bunch more terms of the exact same series that you just built to try to make it as exact as possible, because your calculator is a pretty fancy computer. And so we get that plugged into our calculator. We actually end up with 0.0007445. Again, I only used 2 terms, and I'm within 7.445. Like, that is the 10,000th spot on my decimal. I'm within 8 to 10 thousandths and I only use 2 terms, right? So these are pretty accurate without using a lot of terms.